Hi, everyone. Thank you so much for joining us today for today's Lunch and Learn. I'm Erin Creighton. I am the Adult Services Department Head and Assistant Branch Manager for the Fredericksburg branch of the Central Rappahannock Regional Library. And I am very happy to be joined today by John Bachman, who is a historian and naturalist, and he is here to talk to us today about the Ice
The,
Age in Virginia, which is such
yeah,
a cool topic, John.
it is. No, yeah, it's a cool, great topic, and how appropriate for this time of year after we've been through one of the coldest Januaries in Virginia meteorological history. So
Very much. Take it away, John.
here we go. Okay, guys. This is as somebody that's been studying geology and paleontology a long time. One of the things I realize is that people, you, me, and most of the rest of the humans, or at least I would say all humans, have an impossible time on understanding deep time. Anything beyond 100, 200, 300 years really is hard for us to imagine. So we're going to be talking about dates in here that range from like 2.5 million years to just a few tens of thousands of years. It doesn't seem like 11,000 or 10 or 12,000 years ago is that long. I mean, for some reason, but think of it, the pyramids and were built 5,000 years ago, and of course the Middle Ages, like the 10th century was in the 900s. So when we use dates and times, try to try to conceive of them in a way that you can understand them, because if you kind of lose track of the time and the distances and the lengths of time, then geology and paleontology can be tough. Okay, enough of that stuff. Ice Age in Virginia. Next slide, please. Well, an ice age is a period when Earth's global temperatures drop, causing the polar ice caps to expand. Ice ages can last for millions or even hundreds of millions of years. Okay. The latest of the great geological epochs we know of is that we have named is the Pleistocene. Next. North American glacial stages. Okay, get ready for some phrases in here. North American glacial stages have been named for the Nebraskan, Kansas, Illinoisan, and Wisconsin. They are the places where the glaciers stopped. So the Wisconsin, if you see a map of that, I think that's that sort of peach color there. The Nebraskan is, I think, the green, I think. Then I'm trying to look at the key too. And the Illinoisan is the pink. Now, thank you, Aaron. Yeah, that's where they got to. And so we then, as you may know, or as you soon will know, they've receded and many times gone back. Top pictures, real quick. The middle picture of those scratch marks. And Aaron, if you could point to it, that would be great. Yeah, the middle picture there. Those are scratches caused by glaciers grinding boulders against other boulders. The one to its side, there, the right, the hillside, that's called a terminal moraine. That's the, like, think of a bulldozer pushing up dirt and rock and stuff like that, and finally getting to a point where it can't push them anymore or stops pushing. And this sort of mound, this hill of debris, rocks and soil are pushed up. That's bulldozed by the glaciers. And then that picture at the bottom, and we have some of these around here in Fredericksburg area. Those are called erratics. Those are huge, sometimes massive boulders that are actually picked up by the glaciers, and as the glaciers melt or recede, are dropped in place. So they can come geologically from many different places. Next slide. So there it is again. Evidence from various lines of inquiry have shown these 4 great glaciations in Europe and North America are believed to have occurred at essentially the same time. That's pretty crazy. Take a look at the next slide. That is 18,000 years ago. And obviously, the white is the glacial cap. and what we have today. That's Greenland. And much of the Arctic sea ice is included in that gray area too. So you can see in 18,000 years what's happened. Thank you. Next. Well, the Wisconsin stage of the Pleistocene was the last time that major ice sheets advanced across North America, occurring between 100,000, remember what I said about years and stuff, and 11,000 years ago. So 11,000 years ago, we were pretty close to the glacial front. During this Wisconsin glacial advance, archaeologists have determined that modern man entered North America. Now, we could talk forever on this, but you can find anything on the go on your search engine and dig out first early man or modern man in North America, and you will see those little arrows explaining where some of the theories are that early modern man went. Next slide. Modern humans being modern beings were living in Virginia during the Wisconsin glacial epoch. Did you check that out? They were here 18,000 years ago. The Cactus Hill site, located next to the Nottoway River in Surry County, Virginia, offers accepted evidence for human occupation. The discovery of this site has challenged previous theories about the timing and the routes of human migration to the Americas. Fascinating. Look up Cactus Hill. Crazy story. Next slide. Modern humans were living in the demanding climatic conditions of the Wisconsin glacial period. The picture shows a steppe environment, pretty much what Beringia, that land bridge to Asia, would have looked like. And of course, there is a mastodon on the right, and then early paleo peoples depicting lifestyles of these first modern humans. Next slide. Big question. Will Virginia experience ice ages in the future? Next slide. Well, the answer depends on whether you're talking about a big ice age or a little ice age. If you'll notice the geological calendar there, those arrows indicate where the big ones were. And you notice that they extend all the way down to two of them in the Precambrian, which is the vast percentage or the amount of time on Earth and would not be able to be expressed in a graph. So you see the smaller little arrows in the Quaternary, and then you see one at the beginning in the Pennsylvanian and the Permian, another one in the Silurian, and another one right before the Cambrian. So those are millions and millions of years. Those are the big ones. Next slide. Glacial episodes, okay, that's what we just went over, are the big ones. Interglacials are the little ones. And those pictures, you can see the graph there that represents the ups and downs of the global climate. And you can see that the little, what appear to be like snowflakes there, are the triggering times that showed when an interglacial occurred. Okay, next slide. According to current scientific understanding, there are approximately 20 glacial and interglacial cycles during the Pleistocene epoch. Okay, so 20 times glaciers advanced and retreated, with some sources stating around 17 episodes, alternating with 17 interglacials throughout this time period. Check out the pictures. Notice the yellow, interglacial, and those lasted, tens or hundreds of thousands of years. Next slide. Earth and Virginia is in a big ice age now. which explains why the planet has polar caps. Okay. And they're not natural. There are times in the Earth's history where we've had no polar caps. So we are classified as, kind of euphemistically, a big ice age. Next slide. In the last million years, major ice sheets have grown southward across North America and then retreated 8 times. So here's a big one for today, guys. An ice age isn't one long, continuous, solid, frozen deal. It has been interrupted at least 8 times in the past million years. Now, again, million is hard to understand. It's just, you just have to think of what can I compare it to? 2 level tablespoons of table salt, with each grain of salt being a year. 2 level tablespoons. You might get an idea of what a million might look like. But back and forth at least 8 times. Next slide, please. Ice sheets grow for about 90,000 years. Yeah. And then take about 10,000 years to collapse during warmer or interglacial periods. And then the process repeats itself. The big one is the Wisconsin glacial advance. And the warming ones where the temperature soared, the interglacials where temperature soared for thousands of degrees. Guys, there were crocodiles living in Labrador. There were no polar caps. Cypress and swamp and deciduous forest spread all the way up to well over the 60th degree latitude. Next slide. Given that the last ice age ended about 11,700 years ago, isn't it time for Earth to get icy again? Next slide. Well, we should be heading into another ice age right now. But the planet has been impacted by so much carbon dioxide in the atmosphere, we're probably not going to enter a glacial age. Okay, you ready for this, guys? Or at least another 100,000 years. So things move pretty slowly on Earth in this case. The Wisconsin glacial stage started about 75,000 years ago and reached its maximum extent in the United States about 20,000 years ago. Next slide. Well, during this time, ice covered 25%, a quarter of the continental North America. Now, not all the United States was covered, but if you take North America, the Laurentide ice sheet and the Cordilleran ice sheets, quarter of North America. Next slide. This is what, if you could somehow go back in time, this is what it would look like if you were could go up close to where the glacial front might have been, and that would have been in Pennsylvania, west. It's about central PA. You would drive up there. Well, I mean, you could drive up there, but if you could transport yourself there, you would see something like this. The glaciers extending down. You got the green forest. Crazy image. Next slide. A big part of these cycles of interglacial and glacial periods are changes in the amount of sunlight reaching the Earth. Another reason is that the climatic feedback, like ice, water vapor, and carbon dioxide, in these endless cycles of exchange of atmosphere with the hydrosphere and with the lithosphere and the different components of our planet. Next slide. Over the course of tens of thousands of years, both the Earth tilt and orbital shape around the sun change. Earth's orbit varies from a circle to an ellipse every 100,000 years. Okay. Oh, it does that. Excuse me. It does that because of the orbital characteristics and the mass of the Earth as it goes around in its orbit. It changes from an ellipse to roughly a circle, and then out again. Next slide. Combining these effects with that you just saw on the slide previous, and the amounts of sunlight being absorbed by the planet can vary up to 25%. So 25% of the incoming radiant energy could be deflected or is not absorbed by Earth. That's a quarter of all the sunlight and the associated heat. Next slide. As a result of these changes in the heat absorbed by our planet, every 100,000 years, the Earth cycles in and out of these glacial cycles. Next slide. Well, Virginia experienced significant impacts from the cold climate in the last ice age. That picture is a place called Dolly Sods and is an archaic remnant of what ice age vegetation looked like. You can see it in West Virginia. It's called Dolly Sods. Amazing place. Next slide. Sea levels would drop 400 feet as water was trapped in the ice sheet. The continental shelf was exposed, and the shoreline was 40 to 75 miles east of modern day Virginia Beach. Look at the picture. You see the little the whitish area that's kind of right along the coast there. All that white area would have been land as the glaciers held the water as frozen as in ice, and the ocean levels dropped. Okay, there's Virginia. That shows you the extent of the Laurentide ice sheet. Next slide. The winds, rains, and temperatures of Virginia's paleoclimate were affected significantly by the presence of the Laurentide ice sheet. Cold winds blasted south, bringing only a quarter inch, 25 inches of moisture annually compared to over 40 inches we get today. The sand was blown into huge dunes by stronger winds than we see those of today. So Virginia was different. Yep. Where are you? Right? This is Fredericksburg. Where's Route 1? Just kidding. Fredericksburg, 20,000 years ago. A typical, almost boreal forest. Next slide. For the last 20,000 years, the most recent continental ice sheet has been retreating. And today, ice only covers 11% of the land area. Okay. Now, those pictures, the one up with North America, all those little dots, that's where glaciers are now or have been. And underneath that picture, the western states, glaciers as they exist today. The Great Lakes are the result of the retreat of the glaciers and the melting of the fresh water filling those basins. Next slide. Because of the cyclic warming of the planet, the vast polar caps partially melted. And for the last 10,000 years, we have been in a warm interglacial time period. And because of that, our civilizations have grown, agriculture, man is spread out now over 8.5 billion residents on the planet. When will another big one come, or a little one, or any one come? Next slide. Well, the Milankovitch cycle, that's the cycles that explain the orbit of the Earth and the tilt of the poles and things. When the Milankovitch cycles provide a framework for understanding long-term climate patterns, accurately predicting and timing of the next ice ages, as you can imagine, it's pretty complex and challenging. Next slide. Many factors, including greenhouse gases emissions, changes in ocean circulation, and feedback mechanisms within the climate system can influence the timing and strength of future glaciations. Now, that's a lot there to unpack. Let's say greenhouse gases, got it. Changes in ocean circulation, okay. feedback mechanisms, meaning the exchange, these carbon cycles and nitrogen cycles that are going on constantly to recycle the elements from one state of matter into another. Within all of these things can significantly influence the timing and the strength of the future glaciations, which will happen. Next slide. Recent studies suggest that current interglacial periods may be nearing its end, with some projections suggesting that the next glacial period could begin within the next few millennia. However, it is important to note that the timing of the next glaciation is highly dependent on the continued anthropogenic influence on the climate, and that means our influence on climate. So all of this is up for grabs. This is the best we got so far to understand the complexities that would cause another. It's coming, but it may be postponed because of the heat in the atmosphere. Next slide. The timing of the next glaciation is difficult to predict with certainty, but based on cyclical patterns of past glaciations, the next glaciation is generally expected to begin sometime in the next, get ready for it, several thousand years, perhaps within the next 50,000 years. I know what most people think. Oh man, 50,000 years. Well, the changes don't happen overnight. These perturbations in the slide that you see with the up and down and all of this moving around, all of those things are estimations. They're not guarantees, because we don't still know what the long-term impact of all the carbon dioxide that we're pumping into the air, trillions and trillions of metric tons of carbon dioxide a year. It's changing the planet, and it's difficult to try to determine when these patterns come together for a glacial period. So even though you and I may not be around to see that, there will be humans that'll have to deal with this, and it's out there, guys. Next slide. Regardless of the timing of the severity of the next glaciation, it is imperative that the global community prepares for potential impacts. A future glaciation could have significant impacts on ecosystems, agriculture, infrastructure, and human migration patterns. So we're on this blue marble that we call Earth, and I think we know what the problem is. It's just, do we have the resolve to try to correct it in time before it causes unprecedented changes in the way human beings live on Earth? Next slide is what I'm going to do next, and this is a crazy one. This is the Appalachian Amazon. This is really nuts. So that's coming.
Yeah, that'll be fun too. People really love learning about the local history, John, even if it's stuff like, what was it like during the time of the dinosaurs, or
I
what
know.
was it like during the time of the Ice Age? And honestly, like that picture of Pennsylvania that you found, that artist rendering was so fun to look at, because I think, and I think sometimes people forget what it would picture if basically if we kind of lived in Antarctica. That's what it kind of looked like in our backyard.
Well, if you could go now, I went to see what they call terminal moraines, which is where the glaciers ended in western PA. So I mean, I've seen them, and they are. It's like looking at a series of, I don't know, they're about anywhere between 100 to 200 feet high series of hills that stretch miles and miles and miles and miles. And that's the bulldozer effect of these glaciers. And it's there to say, in fact, in Western PA, there is a great state park called Terminal Moraine State Park. and it's north of Pittsburgh.
That sounds interesting. I'll have to go check that out one day. Thank you so much for sharing this fascinating topic with us. It was really interesting to also see where the coastline used to be. That was really fun.
Well, the Chesapeake Bay didn't exist. It's the flooded Susquehanna River Valley.
You learn something new every day. Thank you
Every
again.
day.
I hope everybody enjoyed this presentation. Like John says on the slide, he'll be back to talk about the Appalachian Amazon in March. So thank you again. Until we see you next time.
Take care.